Okay, so FRQ1 was the one that sometimes C1 asks you to determine if f is best modeled by linear, quadratic, exponential, or logarithmic. And so we did a quadratic and exponential, I think, but I don't think you practiced any of the other ones. So I just want you to know what to write for everything. And so if it's linear, what is the differences that you look at for linear? The first differences. Are those in output or input values? The difference. Output, good. So the question is like something about how the input and outputs change. So what happens with the first differences if it's linear? They don't change. They are constant. And then this is just whatever number they're constant as. All right, and see if you can get these last 5 blanks filled in. We practiced it a lot, so 5 words. Consecutive is so hard to spell. I don't know why. My hand does not want to write it. Okay, consecutive equal length input value intervals. Okay, so see if you can do the quadratic one all on your own. Bless you. So same thing with is the second differences that are constant. Okay, so on exponential, nothing is constant. On well, I guess there. Well, no, yeah, nothing is constant. But the output values change. How do the output values change? Proportionally. That's another word that's not super easy to spell. They probably will have some grace on you. They're not checking your spelling. Just get that point across. All right, and then there's still consecutive equal length input value intervals. And then logarithmic. There is something that changes proportionally. Do you know what it is? The input. Good. And then this is the only one that is consecutive equal length output values. All right, so that could be C, or the C could be all about if the function is invertible. And so if it's a graph, to just check real quick, you can do a horizontal line test, but that cannot be your reasoning. And then if it's a table, you're going to make sure that none of the output values repeat, or that if it's the output values are decreasing and then change to increasing, that's going to be an issue as well. So part 1 is deciding if it's invertible. Part 2 is saying why. And so if a function is invertible, or if f is invertible, you're going to say the reason is that each output value of f is mapped from a unique input value. And then if it's not invertible, then you're going to say something like there are output values of f that are not mapped from unique input values. And then you also have to give an example. So the one that was on the test last year was this one. It was not invertible. They didn't give the point if they didn't give an example of when this happens. So then you would just say something like, for example, f of -2 equals 1 and f of 3 equals 1. So two different input values gave the same output. So that makes the whole function not invertible. Whew. All right.